called the atrium. There's an atrium. We've ripped there on the floor. An atrium. And the auricle is a little flap. Auricle of the atrium is this little flap there. That's the auricle of the atrium. These are coronary arteries. This is the apex of the heart. All right. So, how do we know right from left sides? Well, you can tell by the thickness. So this is going to be the right side. That's going to be the left side. How do we know that? Well, the right side is the pulmonary circuit. The left side is the systemic circuit, right? So think of it, if you're going to pump to the lungs, which are right beside the heart, it's not going to take much pressure. So this is going to be the myocardium is going to be relatively thin, see? Whereas if you want to pump it to the rest of the body, it takes a lot of pressure to go from your tippy toes to your head. So the myocardium is going to be thick, so that's going to be left. It's got to go like that then. So the blood is going to come in from the superior vena cava and the posterior vena cava, also called the precava, postcava, it's given different names, and it's going to come into the right atrium. There's the right atrium there. It's going to come into the right atrium. From the right atrium, it's going to go into the right ventricle. There. So what is the vessel coming, after postcava and precava come in here, and it goes to the right ventricle, and it's going to go to the lungs. So what is the vessel going to the lungs called? Pulmonary artery. Right. Yeah. And there, this is the right. There is the tricuspid valve on the right. So remember, tri on the right. Tri on the right. Bi is on the left. So tri on the right. And there's the cusp. You can see one of them is cut. 1, 2, 3 cusps. There's another piece of the cusp, tricuspid, on the right. This is called the moderator band. It's actually, the name is changed now in some human anatomy books. This band in the right ventricle here, this is a conductive fiber band, conducting fibers. Conductive fibers across the wall of the ventricle here. So you can see these valves, these are atrioventricular valves. See, that's an atrioventricular valve. And it has tendinous cords suspending it, called chordae tendineae. And they are attached to finger-like muscles, the cords, finger-like muscles, so they're called papillary muscles. See? Papillary muscles. So it's going to leave the right, and when it leaves the right, it's going to go all the way up here. This one is cut kind of strange. It's going to go out to the lungs, right? So here is, inside here, we've cut open the pulmonary trunk. It's called a pulmonary trunk at this point. It hasn't split into the arteries. There is the pulmonary semilunar valves, half-moon-shaped valves. So these are pulmonary semilunar valves. So if it's going to come back to the left side, if it's coming back to the left side, let's look at a different one. It's coming back to the left side. What vessels are coming from the lungs back to the heart? Pulmonary veins. And is the blood oxygenated or deoxygenated? Oxygenated. It is coming to the left side, left atrium. And there is the bicuspid valve, also called the mitral valve. The mitral valve. You may have heard mitral valve prolapse. That's when this valve prolapses back into the atrium. The valve doesn't seal, and it goes backwards, and the blood starts going backwards, which is not good. It's mitral valve prolapse. So there it is. There's the chordae tendineae. You can see the finger-like muscles on the chordae tendineae. They're called papillary muscles. The big ropey muscles in the bottom, in the ventricle, the base of the ventricle, are called trabeculae carneae. Trabeculated muscles. It then goes to this one, this big thick left, and it's going to go out to the body. There. That is going to be the aorta. See? It's going to go out to the body, and that's the aorta. And if you look inside there, you will see aortic semilunar valves. And I think I saw it last week too. Inside there is the aortic semilunar valves. There, inside there.
What's that again? Sorry.
This is the aorta, and there's our aortic semilunar valves. See, you can see them inside there. So remember, in systole is the contraction phase, diastole is relaxation. In systole of the ventricles, when it contracts, the blood rushes up through the aorta and the pulmonary at the same time. The aortic valves are pushed against the wall, of course, the semilunar valves. This distends, elastically recoils, and closes the valves, the semilunar valves. When it closes the semilunar valves, underneath the valves in the aorta is the opening for the coronary arteries of the heart. So blood goes into the coronary arteries in systole, the relaxation phase. See? And it goes, so you get surges coming into the coronary arteries during systole. So that, like I told you last time, the lub-dub is the two atrioventricular valves closing, and the dub is the pulmonary and aortic semilunar valves slapping shut together. Lub-dub, 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 like that. And you could hear, if there's backflow, you could hear it if you were trained. When you listen, you'll hear your backflow. You can train, somebody's really well trained, can listen to the heart and tell if there's a problem. Okay? There's the moderator band, and this one is really thick. That's a conductive pathway. All right, let me wind that up.